In this video, we'll generate the trend line of a Legendre polynomial using Rodrigues formula. And we'll also use, this time we'll use COMBINA and sequence and the series sum, Taylor-Maclaurin's series sum to generate the data set and the trend line. So we begin with the equation of the Legendre formula, which is equal to the summation of a times x minus 1 over 2 to the power k, where the value of k starts from 0 to n. And our value for n in this case will be equal to data validation, and we'll have a list zero to 10. Save. Now we have these values to choose from for the values of n. And our k will be equal to sequence of n plus 1 for one column starting from 0 incremented by 1. So if this is 0, our value for k is 0. If n equals 1, the value of k is 0, 1. If this is 2, the value of k is 0, 1, 2. If this is 3, the values of k of 0, 1, 2, 3, so on. Next, we use the Taylor-Maclaurin series sum to generate the dataset, which is array formula, series sum of x minus 1 divided by 2 and raised to the power k, where starts from 0 and incremented by 1. And the coefficient will be from this range. That should be okay. So we have the expansion, and we'll start from here. So if we write 10, assign 10, so this will start from this range. So we now complete the coefficient, which is equal to array formula, COMBINA. This time we use COMBINA, n minus k plus 1, comma k. So if I choose 3, this should be 0. Because this is empty, this should be 0. So we will correct this. So if k is empty and 0, otherwise combine. Now it's corrected. Because this is empty, this should be 0. The second part of the coefficient is combina n plus 1 comma k. So this is times combina n plus 1 comma k, n plus 1 comma k. So here we have the trend line and the polynomials, also the trendline equations. So at n equals 0, the value of y equals 1. So y equals 1. At n equals 1, the value of y equals 1x. So it's a line with a slope. All these are 0. If n equals 2, then y equals negative zero point 0.5 plus 1.5 x squared. All these are 0 because they're very small, times 10 to the minus 16. So 5.69 times 10 to the minus 15, that's very, very small. So they're 0. If n equals 3, which is an odd function, y equals 1.5x plus 2.5x squared, and that's it. All these are 0. N equals 4, y then equals 0.375 plus or minus 3.75x squared plus 4.38x to the fourth, and all the rest are 0. N equals 5, our y is 1.88x minus 8.75x cubed plus 7.88x to the fifth, and the rest are 0. And y equals 6, or n equals 6. Our value for y is negative 0.313 plus 6.56x squared minus 19.7x to the fourth plus 14.4x to the sixth, and all these are 0. And x to the seventh. Our value for y equals negative 2.19x plus 19.7x cubed minus 43.3x to the fifth plus 26.8 times x to the seventh, and all these are 0. And our n equals 8. Y is equal to 0.273 minus 9.84x squared plus 54.1x to the fourth minus 93.8x to the sixth plus 50.3x to the eighth, and all these are 0. 9, n equals 9, y equals 2.46x plus 36.1x cubed, or let's minus 36.1x cubed plus 141x to the fifth minus 201x to the seventh plus 95 times x to the ninth, and that's it. The rest are 0. And finally, at n equals 10, y equals 0.246 plus 13.5x squared minus 117x to the fourth plus 352x to the sixth minus 427x to the eighth plus 180x to the 10th. This completes the use of combina and sequence in the Legendre polynomial equations, or polynomials that use the Rodrigues